Greetings everyone. In this video, I'll try to cover independent and dependent simplicity tests using some demonstration of SPSS software. And I'm Yeshiwas. In previous videos, I have tried to talk about some statistical concepts, and the aim of my video is just to assist everyone who are interested using some statistical analysis and using softwares, right? So independent simplicity test is another name is two-sample test. You can say two-sample test is or is called a between subjects t-test, and this test performs when we want to determine if the mean value or the average value for one group differs from the mean value for a different group on a given target variable. Assume we have one variable and that variable is quantitative, and just the interest is to make inference or to perform a hypothesis to determine if the average value of that variable is significantly different from group 1 and group 2 or not. So this test will use to compare mean differences between separate groups. That's why it is independent actually, because the two groups are separate, and it's only valid if the two groups have entirely different members. So what's independent? Why it is said to be independent? Because a member in group 1 is an exclusive member for that group, is not the group for the member for the other group, and that's why it's called independent simplicity test. So ideally, we assume these subjects are randomly assigned into two different groups, and so any difference in the response is only due to the treatment or lack of treatment, and not for the other factors. What we can assumption before what assumptions should be considered before performing this test? So it needs one categorical variable, one categorical independent or grouped variable, and one continuous dependent variable. So the independent variable is categorical. The independent variable is categorical or grouped variable, but the dependent variable is continuous. Another one is for the equal variance t-test, the observations should be independent and random samples from normal distribution with the same population variance is important. So when we perform this test, we have to check either the variance is equal for group 1, for example, and group 2. Or if the variance is unequal, there will be another test also. So for unequal variance test, the observation should be independent, yes, and there should be random sample of distribution. And anyways, we will have two assumptions about the variance of the two groups. The variance for the two groups may be equal, or the variance for the two groups may be unequal, and we have to keep in mind these assumptions. So this test will test a hypothesis about difference between two group means, and the means are of the same variable but for two different populations, or this can be called as two different groups. It tells us whether there is statistically significant difference in the mean score for the two groups or not. Now we will have a lot of examples when this independent test is applicable. For example, it can be used to compare the salaries of clerks is one group and managers the other group. Is there any significant difference between the salaries of these two groups? The one group is the clerks, and the other group is managers. Is there any difference between the average number of children for Protestant women compared with the Catholic women? Can be yes. The Catholic people is one group and the Protestant group is the other group. Is there any income difference, significant income difference for biology graduates and chemistry graduates? Maybe another concern. These are easy examples. Is there a difference homicide rate? Is there a difference in the average homicide rate of Western countries compared with Southern countries? Also another concern that can be addressed by this independent test. Is there any length of life on average? Is shorter for unmarried persons compared with ever married person? So in all these cases, the two groups have entirely different members, and that's why we call it independent sample t-test or two sample t-test or two population t-test. Let us see an illustrative example how to run the analysis of this test using commonly used SPSS software. In this the case is I will use employee data from the SPSS software. Everyone can access the data if once you install SPSS software actually. And in this video, I am assuming that you are a good user of SPSS, right? So let us see if there is a significant salary difference between male and female employee. So my hypothesis, the null one that should be rejected or not, is there is no significant salary difference between male and female employee. And the alternative is no, not H not. That is, there is significant salary difference between the two genders, that's male and female. And let us see using this employee data. So here I have already opened the employee data. You see, I will have these two groups, that's male and female. Male are one group, and you may treat as one population, and the female are another group. And my interest is salary. Is there any salary difference between male and female employees or not? So there is a salary column, and this is my dependent, and as you can see here, this is continuous variable. And in this one, this gender is a categorical variable. One category is male and the other category is female. So to calculate this independent test, I will go to the analyze menu. I will go to compare means. Then there is a menu which says independent sample test. Yes. So in this one, there is a box which says test variable. The variable I want to test is current salary, right? And I will insert the current salary in this box. So there is a grouping variable. My grouping variable here is gender, right? And I will define here as group 1, group 2 is 2, that's male and female. And I'll say continue and then OK. So here there is a group statistics here actually, and the variable is current salary, gender is male and female. I have 216 female and 258 male. And the mean salary for female is $26,031, and the mean salary for male is 41,441, and with a corresponding standard deviation. Actually, the standard deviation is higher for male employee compared with a female employee, and the mean salary, as we can see here, is 41,441, is much greater than the average monthly salary of female. And this can give you a clue that there may be a significant difference between the salaries of the two genders, and actually it has came to the test output. Here we have to assume equal variance, or equal variance may be true and unequal variance may be also true. Let us see. Equal variance is assumed, and the significant test is the F test for the variance is called Levenshteins for equality of variance. So I will reject equality of variance if this significance level is less than 0.05 and it is true. The significance level is 0.00, and hence I will reject equality of variance, and there is no equality of variance. As we can see in the group statistics, that the standard deviation is very higher actually for male than female. So equality of variance is rejected, and the variation between salaries of male employee is not similar as female employee, and I will take the t-test for equality of means, assuming that the variance is not equal. Here, the significance level is 0.01, and this p-value implies that there is a significant difference between the average monthly salary of female and male, because this two-sided test, the p-value for this test is 0.00. That's actually less than 0.05. That's the alpha level. So this one is the mean difference, and this is the standard deviation for the mean difference, and this is a confidence interval. Actually, if the null hypothesis is true, this lower bound and upper bound should contain 0, and that's not true. 0 is not between these values, implies that there is a significant difference between male salary and female salary, and this is how to perform the independent or two sample t-test. So let us proceed. Another one is I will cover in this lecture is the another type of t-test that's commonly used, and that's paired t-test, paired sample t-test. So this paired sample t-test will perform, and this is a t-test procedure, compares the mean of two variables for a single group. Unlike the independent t-test, this paired test is test procedure for what? Means of two variable, but in the case of independent t-test, that was what? That was one variable, two group. But here, that's two variable and single group, right? So it computes the difference between values of two variables for each case and tests whether the average difference differs from 0 or not. Now, this is one group, but two different occasion or condition. And the common example is the pre-post test or before-after test, right? Another one is data for each paired test specifies two quantitative variables. That variable can be interval or ratio scale. For a matched pair or case control study, the response for each test subject and its matched control subject must be in the same case in the data file. What are the assumptions? Assumptions for each pair should be made under the same condition, right? And the mean difference should be normally distributed. The mean difference, for example, between mean difference for posts pre-post should be normally distributed. Variance for each variable can be equal or unequal. So there are a lot of scenarios which can be tested by paired sample t-test. For example, the average score of subjects on post-test is different than the average of those same subjects on the pre-test. So may compare the average test result for post and pre-tests. Or people will listen longer to a female telephone marketer than very same people will listen to a same telephone marker. Can be another scenario. Or on average, soldiers wait less after they completed basic training than they wait before they start training. After training, before training, can be another scenario. In a comparison of university sociology department, averaged fewer faculty members than did history department. This can be another scenario. First four identical twins live together on average and their second born can be also another scenario. Now, similarly, let us see some illustration how to perform this paired test, or actually this paired test is known as also dependent test, because for example, for the post and before test, the population will not be changed. I will test the same population before intervention and after intervention, then that is dependent. That will be dependent or paired. So let us see if there is a significant difference between beginning and current salary of employees. Using the previous data, I will check if there is a difference between beginning and current salary. Still the employee are the same. Still the employee are similar. But I have beginning salary and current salary after some years, right? Still the employee are the same. So I am interested to see that is there any significant change after some service years? Is there similarity between beginning salary and employee salary? That's my interest. So the formal test is H naught, or the null hypothesis is there is no significant difference between beginning and current salary of employee. H1 or the alternative, no. There is a difference. There is a significant difference between beginning and current salary, or that's to mean not H naught. So let me use the same data. That's the employee data. So here I have a current salary from the distribution. This salary is current salary, and salary beginning is this is a beginning salary, right? It's a beginning salary. So is there any significance between this salary current salary and beginning salary? For example, the first individual or the first observation have a current salary of $57,000 and $27,000. Let us say anyways, because the test will calculate on the average. So I will use the same menu compare means, but now that's paired sample to test. So here the first variable is the current salary. This is the current salary. First one is current salary. Another variable is beginning salary. Still the population the same, but the variable is current salary and beginning salary. Let us going. So here paired sample tests in this table, current salary, beginning salary. The mean current salary is $34,418, and the beginning salary is far below than the current salary, that is $17,000. And the observation is 474,474, and then still the sample size is equal because I measure the same population for the current and the beginning salary. And the standard deviation for the current is $70,000, and for the beginning salary is $7,000. And here another default output is the paired sample correlation. The correlation is 0.88. That's strong positive correlation. Implies that the one who have a large beginning salary may have a large current salary, and as some indication, and the significance is 0.04. Yeah, that's significant. So here is the current salary, beginning salary scenario. The mean difference is $17,403. That this is calculated as current salary minus beginning salary, and that is the average of this difference. And the standard deviation is $10,000. The standard error of mean is $496, and the confidence interval is 16,000 and 18,000. This is positive. So it clearly shows that the current minus beginning salary average is positive, because why? The current salary is greater than the beginning salary. So our interest here is the significancy level is 0.00, implies that H naught will be rejected. If H naught is rejected, that implies there is a significant difference between beginning salary and current salary of employees, and this is how to perform independent t-test. The independent t-test is a paired t-test, and the independent t-test is to population t-test. So in the next video, I will cover also another concepts, and actually if you have some issue of interest to be covered in video lecture, please suggest me in the comment below the video. And if you are interested in my video, and if you appreciate me to continue to cover some portions in statistics, please subscribe, like, share my video to your friends. And for today, that's all about my lecture, and thank you for watching.